I'm going to walk us through next frame prediction. I'm going to be bouncing a lot back and forth between my desktop and other things, so I apologize for the messiness of all my screens, because there will be a lot of them. So basically with this, like, you need the first thing you do is find a video. So I showed the goldfish or the fish in the aquarium thing. I did another one, which was like I wanted to find time-lapse video of like blooming flowers, and it just happened that these would be cacti. So I found this like 4-minute long video, and each of these frames is like, I don't know, like 30 seconds long. So I just used YouTube Downloader to just download the video. You guys probably all know what that is. I don't need to show illegal software in this class, but you know, it exists if you want to find it. So what I got back was I got this video. I then opened it in QuickTime, trimmed it to like a certain length of time. And then the next thing you do is you, so let's just go back to our slides here. So the first thing you need to do is just upload it you have to upload it to Paperspace. So I'm going to turn on my machine. I'm going to like walk through the process of actually doing this. Of course, I'm signed into the wrong account right now, so let me switch around. So I've got this running on one of my boxes here. I'm going to start this up. I'm just going to demo through Terminal because it's a little bit easier for me, but this will also work in CyberDuck. It's just like the actual way in which you upload files might be slightly different.
Sorry, so we can launch an existing machine there?
Yeah, yes, you can launch an existing machine in Paperspace. So the difference between like you can shut it down, or you can like restart it, or you can turn it on. But like, so basically the way these machines work is like I wouldn't delete a machine unless you never want it again. Basically, when you shut down a machine, it stops charging you hourly, and it only charges you for like hard drive space and having a public IP address, and that's charged monthly. So like I would assume that like the second you turn that on, it just charges you for that. But then it won't charge you the hourly rates until you start a machine up again. So that's like, I would generally recommend like leaving the machine like existing on your Paperspace until you're ready to delete the whole thing and just like never pay for it again. But otherwise it's generally good to just like keep them there for the time being. Cool, so I should be logged in here now. Let me just double check by refreshing. Cool, so I uploaded all this software to your machines except Steph's, and I'll help you after class or like after demos to get this all installed. But you'll see here now there's a folder called Epochs HD when you log into your machine. You might not want to log into your machine now unless you want to follow really closely along with me, but it's up to you. So Epochs HD is here. When you open it, you might not have a couple of these folders just because I've already trained some things on it. But the one thing you will have is a thing called videos. So what I recommend, what you want to do is you want to drag your clipped video into this videos folder. I've got a bunch in here right now, but I just dragged in flowerbloom2.mp4. You just drag it in that folder. And the next thing you want to do is you want to log into your terminal. And this can happen either via, you can do this either in terminal and in Mac, or you can use the login or open terminal thing here. The same thing will work. The only thing with the open terminal is it's going to be hard to like pull down files, but this could work. This will work fine for you. In fact, maybe I'll just do it live and let's try it here. I think this will work. I need the password from this. maybe that won't work. All right, well, there goes the live demo of that. We'll try it here. So I'll log me in. I'll make this a lot bigger. So now I'm logged in. So again, if you type in ls, you'll see these are all the folders on your machine. So I want to change directory into Epochs to Epochs. And if you hit tab, it'll autocomplete if you want to be like a power user, but otherwise it's fine, you can type it in. So when I do this, again, in ls, I see all those files that I saw right in FTP. So there's a videos folder, that's where my video resides. So again, I also have I have documented most of this already. So like you should basically be ready to go. If like, and I'll share this link in the Slack as well. This will basically give you the steps to do this process. So the first thing we did is we changed directory into Epochs to Epochs HD. The second thing that we need to do now is, so basically we have a video, and we know what we need from that video are all the individual frames, right? So what we run is we run this script that is called extract frames. What it takes is an input of what the video name is, and then what you want the folder to be named coming out of it to be. A couple other notes that are worth knowing is like I would generally recommend that the video you use be 1280 by 720. This library, which someone else wrote, is like basically built to handle that size. If you do anything else, it might get screwy. So you can even like reformat it to 1280. Yeah.
Can this work with image sequences, or is it better to have the video baked first?
It could work with image sequences, and I can show you what that folder produces, and you can basically like just skip this step and build a folder that has like image sequences in it. But I'll show you how that would work. Okay, so in my demo, my video is named. What is my video name? My video is named Flower Bloom 2. So again, if you hit Option, where you click, you can change. You can like stick your cursor in there, and then so it was .mp4, and then the name. So this is like basically this creates a folder, and you want that folder to be named a certain way. So for me, I just will generally do Flower Bloom 2. Since I already did this, I'm gonna make it V2 just to be safe. But I generally like try to keep my naming like pretty consistent and sane. Otherwise, like you do this like 5 times in different videos, and you're like, wait, which video is which? So it's pretty easy if you just like name things pretty consistently. So this is gonna run. This should only take like, yeah, see, it's already done. That was a really short video, and all it said is like, this is basically like it runs on a thing called FFmpeg, which splits up everything in its own frames. This is the process it ran. You don't even know what that means. It's extracting the frames, and now we're done. So now if I go back to the FTP server, and I go into datasets, you'll see now there's a Flower Bloom 2 underscore V2 underscore dataset, and what's inside there is what's called train frames and test frames. Training frames are basically what it trains on. Test is like, and I'll show you when we output it. It outputs this like little sequence ahead of like doing the next frame prediction. It's kind of cool. I just generally clip it off before we go anyway. So inside of here are just like a ton of frames, and each one is numbered. So if you wanted to just take an image sequence, you could just name them using this sequence, and it would work fine.
And which component expects a 1280 by 720?
The video.
So, but like it's not FFmpeg splitting out the images, it's the thing that's processing the images after.
Well, if we look at this command again, so you pass in.
So it is.
Yeah.
So
yeah.
if we already had frames that were a different size, we'd be okay.
You might be. I think the only thing is when it regenerates the video, it's probably going to try to regenerate it back to 1280 by 720. So it might stretch things, in which case, like, you bring it into After Effects, and you there's a lot of stuff where you can like get happy with it and you'll be fine.
Cool.
The reason that you have to do it that this says to do it to 736 is that for basically for everything in machine learning with images, it has to be a multiple of 4. So 720, I don't know. Anyway, he just decided 736 is the right size. I mean, it has to be a multiple of 16, something like that. But anyway, what he does is like, sorry, the guy who wrote the code for this library. I'm using someone else's library code here, which is great. There's links to that in the doc as well, and there's like, he describes the whole thing, the way he's doing as well. But yeah, so it like converts it to like a slightly weird shape, and then it converts it back down when it does it to video. So the next step after we have like a bunch of images is we gotta start training it, right? So this is the sequence that you want to do. I'm just going to cut and paste it into terminal again. So ignore for now no hub, but Python train video.py, and then it needs a name, and it needs a data root, and it needs a save epoch frequency. We'll talk a little bit about epochs in a second. So all I need to do here really is give it the name that I already gave the project, and give it the root to that data folder. So let me just show you what that means. So name is actually could be anything because you're creating the project now. Again, for like my own sanity, I generally name it the same thing that I name the data set.
Oh wait, you dropped that L and blue.
Cool, thank you. And I think I call it project just so I know it's the project folder. This data root is asking for this folder, the datasets folder. So I can just cut and paste this. It doesn't really matter. Okay, so before I hit run, I'll talk a little bit about, so epochs are similar to iterations that we did in the style transfer, and that what epoch basically means is it means for all the images that are inside of this folder, it trains on each one of them, and that's considered one epoch. So in this case, it's going to run through 202 frames. Then when it's done with that training, it's going to save out the model, and then it's going to do it again. So all epoch means is like, how often do you want to save this out? I'll show you why it's good to save out every one, but you could set it to a different number. And then lastly, the thing that says no hub. So no hub stands for no heads-up display. Again, some computer nerd like in the 80s decided that they needed to be really short and illegible, but that's what it means. What this means is, so this is going to take 8 hours to run or whatever it takes. So when you run this file, if you don't include the no hub and you just hit enter, it's going to run on your terminal, but the second you close your laptop or you like click out of that like window, you're going to lose your connection. It's going to stop running. So what no hub does is it says, hey, just keep doing this like as long as we need to, and don't worry about my connection. So that's all it means. No, you'll have to type in no hub, because otherwise it's gonna like assume you want to write it to the terminal. But yeah, so like, and again, where I think you'll need it is where I've put it in the doc to help you know like you need to use this command. It's basically only when you're training stuff, because training takes time. Testing is pretty quick. We'll go through this. So I'm gonna hit run just to show you what it looks like, because the other thing about no hub is that it doesn't show you anything. So it's literally gonna say it basically outputs all of this content to a file, and you can look at that file. But one of the things that you kind of find out is that if an hour from now this thing throws an error, you won't know here. You'll know in the file, but you won't know. It won't give you a message here. If it throws an error immediately, it'll go back to this. You'll see this line like with an empty cursor, and that means something went wrong. And then what you need to do is you need to go into the there's a file now here at the root directory that says nohub.out. You need to open that and read it. It's a text file, and it'll contain an error message at the very end. So that's basically like what would happen. So I would leave this running for a couple hours. I might check on it every once in a while to make sure it's still running.
How would you do that?
Yeah, that's a great question. So basically, what's going to happen here is, now it creates a new folder called checkpoints, and inside that checkpoints file is going to be so this is what we listed as the project name, right? So we fed that using this name. So now inside of here, there's going to be a thing that they're going to be generating. It's going to generate some things that are called .pth paths. So this is what I previously trained. So these numbers are the number of epochs that it's run for, and then the file is like, this is literally the generator or the discriminator. Like that's really what the G and the D stand for. So one thing that I would do is I would like watch this maybe for the first hour. And I would just see like how quickly do these run. So like the difference between say 3 and 4 is 7 minutes. The difference between 4 and 5 was like 5 minutes. So like that's a way to keep an eye on it. It gets a little bit slower as it goes through it, but basically if like you're an hour in and like it hasn't built a new one, that means that's a good sign there might be something wrong.
Wasn't it in hours?
Yeah, it's quite a
4 and
lot
5?
more.
So I would ignore that because I also stopped it, tested it, restarted it. So like, yeah, that's a bad.
Okay, so after
yeah.
that it is like
I can't do
7
math
minutes.
today apparently.
Yeah.
That's like 5 hours. But yeah, so if you look here, 12:02 to 12:09, that's 7 minutes. That's another 7 minutes. So it's actually pretty consistently 7 or 8 minutes. I think I probably stopped it here again, and yeah. So like, that's a good way to sort of notice. Yep.
So, were you able to resume the progress you had begun earlier?
Yes.
And what does that intervention look like?
So basically what you do is you pass. No. So I'll show you how to do this.
Okay.
And that's actually something that's a good point. I should add that to the recipe. Basically, all you do is you give it this exact same command, and then all you do is say -- continue train, and it just picks up where it left off.
Okay.
It like is sort of smart enough to know that how to do that. So that's all that is. The reason that I stopped this to test it is because I want to see like what my results are. If the results aren't interesting to me, I might just like never come back to it. But let's actually look at this now. So I think like what's really good here is like actually going to show you how to do this. So for the time being, I'm going to do Control C. That just quits that process. Like you wouldn't do that. Actually, let me do another thing because this is actually going to be helpful to look at. I'm going to run it again. Don't worry about it. It doesn't actually matter if I break it. I think it's this one. So I'm going to like, basically the other thing is like when you have that window open, you can't really look at what you're working on. So you have to like do another connection. This is like, you won't normally have to do this, but I'm going to just show you how to do this. So I now have 2 terminal screens. They're both connected to the exact same machine. Like this will happen to you. It'll get really confusing. It happens to everybody. So there's a command that helps you understand what processes are running on your machine at any one time. And it is NVIDIA-SMI. Again, don't ask me why they chose this. It just is what it is. So when you type this tells you, like, this is like system, what is the thing in Mac where it's like you can system monitor? You can see all the processes running. That's all this is. So in general, if it says Python, that means it's whatever our process is running. And this is how much GPU memory it's taking up. So your GPU has about 16 gigabytes worth of space. This is taking up about 11 of it. So it's taking up a huge amount of space to run this model. That's because it's a really big image, right? It's 1280 by 730. Like that's huge. So it's taking up a lot of space. So if I actually want to test this, I have to stop this process, and then I have to test it, and then I have to restart the model again to like do the next step. Because testing it also takes up about 6 to 8 gigabytes of GPU. So like you basically don't have space to do 2 processes in it. Other models will run a little bit lower, and you might be able to get away with running 2 processes at the same time. But it's generally, I would just say like run 1 process at a time. Okay, so the way you do this, and again, there's documents for this stuff, is you write kill-9 and then you like copy and paste the process ID. Again,
Why 9?
-9 is like the command says to like kill a single process.
Oh, okay.
Again, stuff you don't need to worry about as long as you type it right. An important thing is
Type someone's name. Does it kill them?
machine learning is not that smart yet, thankfully. So that kills the process. If I run this again, oops, sorry. Well, if I run it again, it says no such process. If I run that command, you'll see that now the process is gone. So now I can kill this screen and just come back to this thing. Because you'll see it also says killed over here. So you sort of know what happened. So let's say that I have now trained this model for 151 epochs, which is what I did for the previous. It's the exact same video. I ran it for 151 epochs. I want to see what that output looks like now. So let's go back over here. There is now how you test this thing. Oh, and I did type in like how to do this killing of the command, because this happens a lot with this model.
So it took you 8 hours for like 200 images
Yeah,
or so?
yeah.
And that's the train?
Yeah, so epochs will depend on how many images you feed it. So like the time to do it in epoch will actually depend on how many frames you give it.
Right.
I'll also say that I think this model just tends to always look kind of messy and funky and fun. And it never needs to train much more than like a couple hours to do that. If you wanted to get to like perfect fireworks, like that would maybe take a day, and I'm still not sure it would work. Like this model just produces like weird looking shit, and that's what's fun about it. But it's a little, you sort of like don't really need to do a lot with it to make it look like that. Yeah.
What if you initiate a process that exceeds the GPU memory?
It'll throw an error. It'll basically tell you like, hey, we don't have enough space for this.
Can it do that before you initiate it? Like, is there any kind of calculation?
No, it'll just kill that process.
Okay.
That'll be it. And it'll either stop all processes on the GPU, or it'll stop, or it won't let you do the one that you already have.
Okay. And so I'm assuming that this, when it's running, it takes up as much of the overall capacity.
Yeah.
It's not like incrementally growing with every epoch.
No, but this model in particular does actually grow a little bit more as it gets further along in the process.
Okay.
So that's why I generally say like just do one process at a time. Because you do multiple, like they might eventually run out of space because it's trying to grow a little bit, and then it won't work. So it's just easier a little bit. That's also why I have you do the P5000 machine. Is P5000 has 16 gigabytes. The P4000 has 8 gigabytes. So like, you actually can't even run this model on the P4000. It's just not possible. So yeah. Any other
Have
questions?
you played around with it with a smaller number of frames? Like, if you give it, like, how many frames are you working with on this one?
202.
Okay.
So my guess is the more frames you give it, if it's actually like a good, like something like fireworks, which is good because it
Yeah.
sparks and then it sparks again. Like you could train that on a pretty long sequence and it might actually learn what it needs to do.
Right.
So yeah, that's kind of one of those things where you need to play with, like, how long do I train it for? The model the size of the process is actually dependent on how many pixels it is, not how many frames it is. But yeah, so like that's something that's like worth playing with here is like how long of a video is good, how like what types of videos are good, those sort of things. Yeah.
One other thing.
Yeah.
Didn't you recommend to do like 1,000 images?
I did, but yet I did one that was on less and like
And
it kind of
was
works.
fine? Okay.
Yeah. Here, I'll show you what it looks like. So the command you run is, wow, okay, let's see. Oh, I know what's going on. So sometimes when you cut and paste these things, it assumes you want the end of line, and I don't actually want the end of line, so I'm just gonna like,
Then you have to specify the project name, right?
yeah, so that's why I threw an error, because I gave it a dummy. So the command is Python generate video, and then it's looking for a name, and that name needs to match the name we already gave the project, and then the data root, so it needs those images again. And this is where it's asking for images in that test folder. And then how many, I'll talk a little bit about this. This is how many frames it produces. But let me just run this one, and then we'll come back to it and look and see what happened. Because this will only take a minute or two while I do this. So the thing I want is this project.
What did you do to move the cursor?
Option click. Yeah, option click works. Yeah, terminal is like its own language. And then I want the data set for flower 2. So then you're also saying frames per second is 24. How many? 200 frames. So you can do the math here, and it's like less than 10 seconds. But it's a good enough example to sort of show you how it works. So this is going to run. So it's looking at with that test frames folder, and you can actually, I'll show you how like you could actually change this. But then it's telling you how many frames are in that test frames. And now it's going to actually produce other images. So like 200 frames happens pretty quickly. Are there any questions while this runs?
How long was your video? Like, to
It was
start?
like 15 seconds or something. It was pretty short. and you'll see like the training ends up being like kind of a disaster, but like a fun disaster. I think because it was so short, because there's not enough repetition in it, so it can actually learn things. That's sort of my theory. That's why fireworks work well, because it's like repetitively telling you how this thing works. So like maybe what I would actually want to do is like duplicate that sequence like a number of times and then see if it learns. Yeah, exactly. So like here again, like this is stuff where like I've seen like 3 people use this process before, so like we don't know enough about this to actually understand how to improve it or how to work with it well.
Do you upload your own images, like instead of doing it
Right.
like that? Do you have to name them like 1, 2, 3, 4?
I'll show you how to do that. But yeah, you could do that. In general, like the other thing I would say is if you upload your own images and it's on something different than you train, like it very quickly like degrades back to what you trained it on. Maybe I might have an example of that.
Okay.
But yeah. Okay, so it just made all those frames and now it just output a video for me. So like I have a video now. So if I go back here and I go to the project and I go to, it's this guy, and I have a folder called output. You'll see I've output this many, many times. So this last file is actually the one that I want.
Why does he output so many times?
I've tested this like many, many other times. I've ran this exact same process like multiple times. If this were a brand new project, you only see that one file.
Oh, okay.
Yeah, yep. So if I open this,
That's cool.
So
yeah. So and that's what it is. So remember how I told you that the test frames are like pre-generated? So that's what this like original video thing is. So all he did in the guy who wrote the library, he wrote the code to like he just like stitched those first 60 frames up in front of the frame generation.
Sorry. The starting point is always going to be the first 60 frames, according to how this is being constructed.
According to how this has been constructed. So basically, like what's actually happening here is we're now up to our video, and then we start seeding the image like where it starts to dissolve. So if you actually look in here, if you were to look in the frames, no, that's not right. That right place.
So it plays the actual video and then it...
Yeah, so what he does is if you go in here and go into data sets and then flower bloom, see how there's test frames? So when you actually open these up, like it's seeding in this before your own video. So generally what I'll do is I'll download that video and I'll trim that off because it's like, okay, cool, whatever, that's fine, but like I don't actually want it. Yeah, so that's the whole process. So like from a like design standpoint, like you don't have to do much. You just have to wait a while and like pay money to Paperspace. But that's it. So there's some cool options within this that I think are worth talking about. Yeah, go for it. Yeah.
But so you only use the first frames of the video, and then the rest is like quickly generated.
Yes. Yeah.
I thought actually what you meant like a few frames here generated, a few frames here. So then like kind of has a starting point, end point.
So you could do that. You could do that, but you'd have to like basically do a couple pieces manually and then stitch it back together. So in here, I have. Okay, apparently I didn't actually write this out, but there's some additional options that you can run. Maybe it's in my slide deck. Let me see here. Yeah, so here are some options that you have available to you. So we talked about how many. That's the number of frames, right? So let's say I wanted to, say I wanted like an hour of this, right? So it would be, what would it be? It would be 60 times 60 times 24. So I need that many frames. It could produce that, but it's going to take a while to actually generate those. But you could do it.
And is that going to change the speed, or is that going to change the, like, is it just going to go further and further and further from?
It's just going to go further into space. So like basically what it'll actually do is the first, like compared to the 200 frames, those will be the exact same 200 frames. And then after that, you'll get new stuff. But I will say that depending on the model you have, sometimes they'll go to all black or all white and then nothing will happen. So like, you might want to like iteratively test your way up to an hour instead of like waiting 30 minutes for this thing to generate and then find out that it stopped 2 minutes in.
Again, the main part that's the most resource intensive is the training part. It's
Yes.
not the actual image construction. part.
Yep. Yeah. Because so again, think about what a neural network looks like. and how you've got 10,000 nodes at the beginning, and then you've got 10,000 nodes at the end. You've got all these layers in between it. You're training every one of those nodes. So that could be billions, or I don't even know what's past billions, but like it could be a shit ton of nodes that you're training. The image generation is just passing that through that network once. That's all it is. So it's really fast to do that. Whereas like with the training, it's like forward once, backward once, forward once, backward once, forward once, backward once, like over and over and over. So that just takes a lot of time. It's very intensive. Yeah. Cool. So some other options. So remember how I talked about epochs? So you can pass in a particular epoch. So let me find a video here that I've done. So I passed in a couple different epochs. So here's, if you look at the left, these are on my desktop now.
I forgot what an epoch was. Sorry.
So epoch is how many times it's been trained.
Oh, okay.
So, and the thing about this particular model is it's pretty volatile. I think in part because I'm training on a small number of frames. But so again, an epoch essentially would be like pass through, back, 200 frames times. But each of those epochs will give you slightly different results in terms of like what's actually been produced. So when I produce the video on, let me try 40. So also it'll, like when you pass in that which epoch, it'll like generate a video. The video name will like tell you which epoch it is. So I got some weird like disco lights out of this one. So because you're training it on an epoch, the model is slightly different every time you save out an epoch. Because it's relearned those frames, and maybe it's learning different ideas. So this one was totally different than that last one, right? Like, and that's the thing is like that's why I generally say save out each epoch, because you might want to go through it and be like, which one's better? Is it 151? Is it 150? Is it 148? Is it 149? It's worth testing because I think like, so I have 145 here. So that one has like weird flashing in it.
Wow.
Why?
It's just, again, what the neural network has decided it learned or like what it's working on. So yeah, all you have to do then is just pass in a different which epoch. So when we first ran this, you'll see we didn't pass in which epoch at all, and it just assumes the latest. So it grabs whatever the latest version is. So if I were to do this here, I would say which epoch, and I've never tested it on 80, so let's just try 80, and I'm gonna hit enter.
And where's the 80? Where does that number come from? That's just a random one? Like you could put any random number?
Is that like the 80th attempt at?
So that number comes from, and this is important to know, is like it has to be a number that exists in this folder, because these are all the networks. So basically, like if you look at this, it's like this is the 151st epoch of time that you train the network. Then it's the 150th, then it's 149th. So if I were to delete 140 and then try it on 140, it would say I don't have that. I can't do that. So what is the number itself? It's sort of like, well, I know I've trained up to 151, so I can choose any number between that, because I also set it to save out each epoch. So I think that's, yeah.
Well, so these are not, it's not important that 141 have access to 140. It is a discrete instance or an understanding.
Correct. Now, if you were to delete the thing that says latest net D and latest net G, and then you try to continue to train it, it's going to say, I don't know what to continue to train from. So like the only things you don't want to delete from here are the ones that say latest, because that's going to like, you basically will never be able to continue from that path. But what I also think is really important to note is like, look at how big each one of these files is.
Wow.
And remember like how much space is on your machine. So like with this model, like I'll check it every couple hours and I'll stop it, I'll test it, and if I don't like a model, I'm gonna toss it out. Or like I might drag all these into my desktop because it's gonna save me some space. So just keep this in mind, like you're also gonna blow up your hard drive space a lot with this model. So you wanna keep an eye on it and make sure it's good. I was gonna run this while I was talking. Yep, okay. What other options do we have here? So the other option is we can say start from. So this would be like, let's say that like for whatever reason, like I don't like the 60th frame of this video, and like that's what it starts with, right? Anytime you run this particular that particular command, it's always gonna take that 60th frame and start with that. So let me just say, and actually I've never done this, but let's try it. Let's say I want to start from. I'm actually just gonna kill this, and we'll do this again. So I'm just gonna do it from the latest, and I'm gonna say start from. Now here's where it gets kind of annoying, is you're gonna have to figure out like what the path to that frame is. So in this case, I know I want it to train on. So let's just pick this frame. So let's pick from the, what is that actually? Let's actually look at it and see what it is. Cool, yeah, let's pick that one. So what I would generally do is, at least in Terminal, and I think in CyberDuck too, you can copy the URL. And then this is where it kind of like, you have to like kind of know how a machine thinks. If I paste that path in, I get this crazy long URL. But what I really only want is, I'm already in the Pix2Pix HD folder. So what I really want is just this. So what this is saying is, it's saying start the next frame prediction at the 3rd frame. So I'm just going to run this and we'll see what it does. It's going to take a minute or two. Any questions? Any thoughts? Does anyone want to do some of this? Okay, cool.
Make me help.
The nice thing about this is like, you don't really have to think a lot about like finding a source, right? You find a cool video, you try it, you see what happens. You go from there.
I mean, it's a really dumb question.
Yeah.
I don't know my response goes, but why isn't there like a software that can like upload a video?
So I think this is basically what Runway eventually wants to be.
Okay.
The reason that no one has it is because no one's asked for it, or like if people ask for it, no one's built it for them yet.
Okay.
So like this will, I know Runway is working on training stuff. The problem with training is it's going to take a while, right? So like you don't want to pay 5 cents a minute to train something for 8 hours. So they're trying to figure out the business model of like how to make that a little bit cheaper, and then how to actually do it. So like, are you going to keep your Runway laptop open for 8 hours? Like, there's like technical concerns about that. That's why like I can teach you this way, which works, but it's like clearly like kind of frustrating and like a little annoying if you don't know what to do with each of these. Yeah.
Is there any way to control how much GPU RAM gets used?
Not in this model. There are in other models. Yeah, I don't know. I would basically assume the answer is no for some of these things, but.
And presumably it's not sharing RAM between, because like I have like a
So
6
you can train it across multiple GPUs, but that's something I've never done because I've never had multiple GPUs. And I've heard it's mixed results whether that actually works. Yeah. All right, so this guy has built for us. It's this last one. So that's what happens when you train it from the 3rd. It actually almost opens, but then it still dissolves into craziness. Cool, okay. Any questions before I show how CycleGAN works? All right, cool, let's move on to CycleGAN.